So firstly, you select this binding, which is a primary binding, and drop this binding right here. Okay. Then you select the armature and drop this armature right here. Then you select the secondary binding and place that secondary binding right here. Okay. After this, what you have to do, you have to configure the LVDT. Okay. So you have to select the number of turns for this LVDT. If you give 1000 number of turns, so primary consists of 1000 number of turns, whereas secondary is divided into two parts. So first winding consists of 500 number of turns, and second winding consists of 500 number of turns. Okay. So it's up to you which value you have to select. You can select it, and this winding will be configured with the 1000 number of turns. Okay. Now you have to select the voltage in RMS. Okay, root mean square value of this voltage. So we are going to select a 7 volt RMS value. So it's a amplitude. Okay. Then we have to select the frequency. Okay. So you can select frequency with 1000, 3000, 5000. It's up to you which frequency you want to select. Okay. I am selecting right here 1000, okay, hertz frequency, and I am clicking on this configure button. Okay. So when you click on the configure button, you will find the LVDT is showing the displacement right here. Okay. So this is the positive sign. If you move this core toward movable core toward the right hand side, your displacement will be positive. Okay. If you move this core toward the left hand side, your displacement will be negative. So click on the plus side. When you click on the plus side, you will see the waveform is changing in red color right here. So this red waveform you will observe right here, its amplitude is changing. And on the graph side, you will see the value of this particular displacement, okay, is also changing. So at this particular moment, the dot of this red color will be shown right here, and when you scroll your mouse over this red dot, you will see the displacement over it. Okay. So again, what I will do, I will click on this plus sign. Okay. You will see the waveform is increasing, its amplitude is increasing, and a displacement is also changing right here. Okay. So again, if I will click on this plus sign, you will see displacement also changed to 4, and amplitude is also changing. Okay. So in this manner, you will see the displacement of the LVDT. This value reach at 7. Okay. And amplitude is also reach at some level. Okay. So this is the positive displacement right here. When you move this core toward the left hand side, what will happen? You will see this red dot is moving backward. Okay. Means your displacement is decreasing. Okay. So when you make this particular core at a center level, its its voltage level displacement is 0. Okay. When you move this particular core toward the left hand side, you will see the amplitude again increasing toward the negative direction. So you will see this is the negative direction. When you increase this core toward the right hand side, your amplitude is increasing toward positive side. So one axis is the voltage, that is in millivolt, and second axis is the displacement. Okay. So you will see when I will move this core toward the left hand side, the displacement is also moving toward this negative direction.